Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to talk about averages. In business, you're going to encounter three different types of averages. There's simple average, weighted average, and geometric average. So in this video, we're going to define what each of those averages is and do examples of how to calculate them, and then talk about when to use what type. The first average, called simple average, is probably something you're very familiar with, and it's the easiest one to calculate. It might also be called the arithmetic mean. This is the notation we'll use for simple average, and all it is the sum of the x values or the data values. So this symbol here is sigma, and it just means sum. So you add up all of your values, and then you divide by the number of values that you have. Our first example says we have a set of test scores, so maybe a student has written 5 different exams, and these are their 5 scores. In order to find the simple average or the mean, you're just going to add up all of those test scores and then divide by the number of test scores. So we have 1, 2, 3, 4, 5. When we add those values up, we get 375. When we divide by 5, we get 75. So the average of those 5 numbers is 75. Our next example says, what's the average salary for an analyst based on these salaries here? So 65,000, 80,000, 58,000, and 70,000. Again, we're just going to add up all of those values and then divide by the number of values we have, which is 4, to get an average of 68,250. When not all of the data values share the same level of importance or occur with the same frequency, then we need to use a weighted average. And the weighted average takes into consideration the weight of each of those values. A prime example of that is when you're figuring out a final mark in a class. Different scores that are obtained in the class are worth different weight. So in order to calculate the weighted average, you have to multiply each of your data values by the weight and then add all of those products up. So this is the sum of W times X, where X is the data value and W is the weighting factor. The denominator will be the sum of the weighting factors. Let's take a look at the example to illustrate how we use that formula. So we're finding the final grade for a course, and it's based on 5 exams. 3 chapter exams worth 15% each, 1 midterm exam worth 25%, and a final exam worth 30%. These are the weighting factors. A student scores 60, 70, and 75 on the chapter exams, 80 on the midterm, and 65 on the final. These are our X values. These are our data values. So given these scores and this weighting, what is their final mark? Let's start with our first exam, which is worth 15%, and this is the score. So we take 15% as a decimal. 15% is 0.15 of 60. We do the same thing with these next 2 scores, 15% of 70 and 15% of 75. Then the midterm exam has a weighting factor of 25%. So we take 25% of the score, which is 80. And lastly, the final exam, 30% of the score, which is 65. That is the sum of all of the weighting factors times the test score. And then our denominator is going to be the sum of the weighting factors. The sum of the weighting factors is 0.15 plus 0.15 plus 0.15 plus 0.25 plus 0.3, which should add up to a 1. Now let's calculate. So the numerator will be 70.25, the denominator is a 1. So the final mark in that course will be 70.25. Our next example says an investor placed $500,000 into 3 different investments as follows. $100,000 in a fund that in a year had a return of 6.95%, $300,000 in a stock fund with a return at the end of the year of 10.72%, and $100,000 in T-bills with a return at the end of the year of 2.75%. So again, if we want to find this average, we can't simply find the simple average of those three amounts because there's different amounts invested in each of the funds. So we have to do a weighted average. In this example, these are our data values. That's what we're finding the average of. What's our average percent of return? So those are our X's. And the weight will be the amount that's invested in each fund, or the frequency. So 100,000 is the weight times the data value of 0.0695 as a decimal. 300,000 is the weight times the data value of 10.72% as a decimal is 0.1072. And 100,000, the weight, times the X value of 2.75%, which as a decimal is 0.0275. Our denominator is going to be the sum of the weighting factors, which is 100,000 plus 300,000 plus 100,000. Or we know we were investing a total of 500,000. What this numerator represents is the actual money earned on each investment. We sum that up, so $41,860 will be the total amount earned on all three investments, divide by our total amount invested of 500,000, or our total weighting, which is 0.0837, and as a percent, that will be 8.37%. If we just took a simple average of those three values, it wouldn't be correct, because more money was invested in a fund with this return compared to the other two, and you have to factor that in. Let's do one more example with weighted average. A retail store sold 200 headphones at the regular price of $250 and 75 headphones at the sale price of $150. What's the average selling price? So that tells you the data value is the selling price. The one X value is $250, the other X value is $150. The number sold at each price, that's the weighting factor. So we had 200 at this price, 75 at this price. And I think you can see that in order to find this average, we can't simply take the average of our two prices because we didn't have equal numbers sold at each price. If we did, then it's a simple average. But this is a weighted average because we have different frequency at each price. So the weighting factor for regular price is 200 times the price of 250. And the weighting factor for the sale ones is 75. So the weighting factor times the X value, weighting factor times the X value, divided by the sum of the weighting factors, which would be 200 plus 75. And what these numbers represent is the total money brought in for the headphones sold at the regular price, and this is the total amount of money brought in sales for the headphones at the sale price. So this is the total amount brought in for both sale and regular price headphones divided by the number of headphones sold. And when we calculate that, we get $222.73. If you think about it, it makes sense that it would be closer to 250 than 150 because more were sold at the regular price than at the sale price. So the key thing in doing weighted average is understanding what your X values are and what your W values are. Now let's move on to geometric average. The geometric average is sometimes referred to as compounded annual growth rate or time-weighted rate of return. It's an important tool for calculating portfolio performance because it takes into account the effects of compounding. A huge benefit for using geometric average is that the actual amounts invested don't need to be known. It focuses entirely on the return figures or the percent return. Formula for finding geometric average looks fairly complicated. You're going to have a variety of percent returns. So with each of them, you add that percent to 1, multiply it by 1 plus the next one, and so on. You keep multiplying by n represents how many there are. And then you take that product and raise it to the power of 1 over n, and then you subtract a 1. Let's take a look at an example because I think then it will become easier. So our example says a portfolio returned the following amounts each year for 5 years. In year 1, at the end of year 1, 5%. At the end of year 2, 3%, year 3, 6%, year 4, 2%, year 5, 4%. In this case, we can't use simple average. And the reason for that is that each year that investment grows. And so the amount being invested in the next year is a larger amount than the previous year. So it's not equal weighting for all of the different percentages. Therefore, geometric average makes the most sense. So to calculate this, I have to take the product of 1 plus the percentage return for each of those years, raise it to the power of 1 over n, and minus 1. So we have 5 years, our n is 5. So we'll have 1 plus 5%, 0.05, times 1 plus 0.03, and so on. Take that product, raise it to the power of 1 over 5, and then subtract a 1. Simplified, that'll be 1.05 times 1.03 times 1.06 times 1.02 times 1.04. So when we multiply these values, we get 1.2161. This base to the power of 1/5 is 1.0399. When I subtract a 1, I get 0.0399. That's 3.99%. So we would say that portfolio had a geometric mean over 5 years of 3.99%, which is a different value than what you would get if you just added up these values and divided by the number. So those are the 3 different types of averages. You're going to use simple average if all of your data values have the same frequency or level of importance. If they don't, you're going to use your weighted average. And if you're talking about average growth rate or return rate or percentage change over time, then you're going to use your geometric average.